We now move to the second unit on transfer, conceptual change. In this unit we discuss the impact the use of knowledge has on the knowledge itself, so the way the learner changes the knowledge network on the basis of using the network and using the knowledge, applying the knowledge, so transferring the knowledge. So this is a sort of next step after you have transferred knowledge to a new situation. You will discover that the knowledge helps you to solve problems in that new environment, or you may also encounter problems with the knowledge itself, and you realize that you have to change your conceptual structure. There may be misconceptions at stake. The misconceptions are knowledge structures, concepts, theories, which are consistent and coherent and which do help you to understand the world around you, but they consider flaws which cause you to misinterpret a situation or mispredict what may happen in a situation. You are not able to solve a particular problem because the conceptual structure you're using is not completely fit to that problem or that situation. So misconceptions are, let's say, situations in which knowledge does not do its proper work. Let's look at an example of a very famous misconception, and that's the idea that the Earth is the center of our solar system. This, of course, has been a very influential misconception. It has been the cause of debate and struggle, and people have been killed for announcing or proposing another solution for the idea how the solar system is organized. This is a theory. It does help you to make predictions. It is coherent and consistent, but there is a flaw in it. So that's a misconception, basically. Now the question is, how do we change our knowledge of the world on the basis of using that knowledge? And Rumelhart and Norman have proposed, in fact, in their schema theory, 3 ways in which people adapt their existing knowledge in order to be able to deal with problems in their environment. The first step is, the first way of changing your knowledge is simply accretion. This does not, in fact, imply a major change in the existing knowledge structure. It's just a matter of extending the nodes, the network of nodes, with new nodes which do cover new phenomena in your environment. So you simply add to your existing network new nodes. For instance, in this particular example of the solar system, you add new planets to your representation of our solar system. You give them a place just on the occasion of discovering these new planets. So the model itself is not changed. There are extra planets added to the model. That's a matter of accretion. That's what we do on a daily basis when we learn new things. We extend, we let our network of knowledge grow. The second step, the second way to adapt is tuning, and this does indeed imply some changes. For instance, you may discover that concepts do have a wider applicability than you originally thought they had. Your concept cat may be extended to cover other animals encountered in other houses which have the same characteristics and which are also called cats. So you gradually extend your range of applicability of the concept cat. There is also the possibility that you restrict the applicability of a particular concept. For instance, if we turn again to our geocentric solar system, you may discover that some phenomena you encounter are not adequately dealt with by your geocentric solar system model. So you note exceptions, so to speak. You say, okay, in these particular cases, the model does not work. And okay, so we have, of course, in every concept, we may have exceptions to the rule. And we just note these exceptions and take care of them when we encounter them again in a new situation. And we say, okay, this is an exception to the rule. So we have a rule, it does work, but not in this case. So we have to make an exception for this case. That is also a matter of tuning the existing rule. So you restrict the applicability of the rule, in fact. Now, you can imagine that, particularly in this example of the geocentric solar system, you get more and more phenomena and cases in which the model does not hold. The model does not properly predict what is going to happen. So there is a gradual increase in the number of exceptions and a gradual decrease in the applicability of the model. This change in number of cases in which the model does not hold may eventually lead to a complete turnover of the model, a complete restructuring. That is a very difficult step to take because the models are knowledge. In this case, the geocentric model of the solar system is based upon deeply entrenched presuppositions, as Stella Vosniadou is calling it. So deeply entrenched beliefs. In this case, of course, we know from history that the geocentric model was related to the idea of a god taking care of everything and placing the earth in the center of his, let's say, creational work, and mankind is in the center of the world again. So the idea, the geocentric model was attached to the generally held belief within the Catholic Church, and the idea that not the earth is the center, but the sun did contradict with these deeply entrenched presuppositions. Therefore, people were killed, like Galileo, for instance. So the changing of the complete restructuring, which is sometimes and very often necessary, does not take place in an easy way, in a gradual way. It is a sort of revolution which has to take place within science or within your personal beliefs, that you have to completely let's say, wire your network and put things in a completely different relationship. So that is what takes place in restructuring, and that is the final and the most important way conceptual change does take place. Okay, so now we have discussed learning phenomena, we have discussed transfer phenomena, and we are able to move on to the last unit, which is a sort of, collection of guidelines how to foster learning and transfer.